Welcome back, everybody. Today we will be talking about polar equations of a circle and also line, as you can see on the title. So we'll go ahead and begin with the general equation of a line in polar form, which I wrote over here as r is equal to c divided by a cosine theta plus b sine theta. Now I am going to take this and I will convert it back into Cartesian just to verify that it is going to be the equation of a line. So let's go ahead and start by multiplying this equation both sides by the denominator. So we would get a multiplied by r cosine theta plus b multiplied by r sine theta is equal to c. And if you remember, for our polar, r cosine theta is the same thing as x, so we can replace that there. And r sine theta, that's the same thing as y, so we can make a substitution there. So what we have now is your standard equation of the line, ax plus by is equal to c. Now, if I give an example of this polar and I want to sketch out what the graph actually looks like. So remember, I would like to prefer not to convert back into Cartesian if possible, just so that we can get used to having this practice, because once you get to calculus, we actually try not to, if possible, to make this conversion, just to save a little bit of time. So let's go ahead and think about how this actually works out then. So first, remember that this is an equation of a line because of what we just said previously. And in terms of how do you draw a line, the best way I can think of is go back to, I guess, algebra, where we can say, hey, if we can find 2 points on the line, then we can just go ahead and connect the dots, and then we're pretty much good to go. So that's what we're going to do over here. So we'll go ahead and keep in mind that theta is usually our independent variable and r is going to be our dependent variable. So we'll go ahead and choose values of theta to plug in. So I'm going to go ahead and first say let theta equal to maybe 0 degrees, something simple that we can use. So r is equal to 12 divided by 4 multiplied by cosine of 0, which is equal to 1, minus 3 multiplied by sine of 0, which is equal to 0. So r in this case is equal to 12 divided by 4, which is equal to 3. So our coordinate, one coordinate that it contains, is going to be 3, 0 degree then. And I usually try to write my polar coordinates in terms of brackets, so then that way you can see that this is a polar equation and not a Cartesian equation. I will now go ahead and let theta equal to a different value. So let's say this time theta is equal to 90 degrees. So r, in this case, is equal to 12 divided by 4 multiplied by cosine of 90, which is equal to 0, minus 3 multiplied by 1, because sine of 90 is equal to 1 then. So to clean up this equation, we now have 12 divided by negative 3, which is equal to negative 4. So that coordinate is going to be negative 4, 90 degrees. Or if you want to make this a little bit easier, that's the same thing as saying 4, 270 degrees, just going so that we can have a positive radius. Now let's go ahead and sketch out the graph of this, and so we can figure out what the graph actually looks like, hopefully. So let's see, 3, 0 degrees, so that means that we're going out 3 units in the 0 degree direction. So this is going to be our coordinate right here. So let me just go ahead and put that in. So 3, 0 degree. Whereas for the other coordinate, I will put, let's see, 4, 270 degrees. So we're going to go down by 4 units. So this is going to be located right here. So 4, 270 degrees, or if you want, negative 4, 90 degrees. But regardless, we have 2 points we can work with. So now we can go ahead and connect them, and that's going to be our equation of the line then. Okay, so again, try not to convert into Cartesian if possible. Just try to get the practice as much as you can so you can get more familiarized with polar. So this time, let's say that we have to find the equation of a vertical line that goes through the point negative 6, 150 degrees. So I will go ahead and draw an illustration on the side just to show you what I'm talking about. So let's say that we have a point somewhere, just arbitrarily, negative 6, 150 degrees. Now, since we're looking for a vertical line, then that means that this is basically what we're looking at. And the equation of a vertical line is always going to be x is equal to something. So what I'll do on the side is the following then. I'm going to go ahead and write x is equal to r cosine theta, which is basically the equation that we've been using for since the beginning of this polar thing. I know what r is because that's given to us, and I also know what theta is because that's given to us. So we can say -6 is going to be multiplied by the cosine of 150 degrees. So essentially, I'm just basically trying to solve for x is equal to. I will go ahead and keep solving for this. -6 multiplied by cosine of 150, which is equal to √3/2, and that's also negative. So the two negative cancel out, giving us √3 multiplied by 3, and that's supposedly equal to x. But remember, I don't want to solve for this in a Cartesian form, but instead I want to solve for this in polar form. So my final answer is going to be r cosine theta is equal to 3√3 then. Okay. So I guess depends on what the question is really asking for. If they want in polar, then you can give them r cosine theta is equal to this. If they want Cartesian, then x is equal to 3√3. And if they don't say either one, you could just go ahead and give them either one. So now let's go ahead and look at the equation of a circle, which is a little bit more difficult, but it's actually not too bad. You can bear with it. I have a circle where the center is going to be located at some coordinate and polar coordinate that is called r of 1, comma thetas of 1. I have a circle, also the radius is going to be equal to a, so everything is written here. Assume that the center of the circle is that polar coordinate that I just said, and the radius is equal to a. Now, p of r of theta is going to be any point that's on the circle, so that is going to be kind of like our variable over here. So let's go ahead and start by drawing a little bit more here, so you can see how to relate everything then. So we're going to go ahead and draw this line right here from the pole all the way to that variable point. The value of r is supposed to be over here, that line, the length of that segment, and theta is going to be the angle of rotation, so that is going to be located right there. Now, similarly, I am going to go ahead and create a line segment from the pole, the origin, whatever you want to call it, all the way to the center of the circle. So there you can see that r of 1 is located in that line segment, and theta of 1 is going to be that length, that angle right there. Now I will go ahead and look at that triangle and notice that we can kind of, I guess, solve a little bit more over here, and I will go ahead and do so on the side. The angle that is in between the two right here, this angle right here, we can go ahead and denote that as theta minus thetas of 1, and that actually is going to be pretty essential. In the triangle, we have three sides and we have one of the angles, and the one thing that comes to mind is the law of cosine from last semester. And for those of you guys that don't remember the law of cosine, let's go ahead and write it out so you can see how that actually works out. So it says that if you have a triangle, and let's go ahead and say that this is going to be x, this is going to be y, and this is going to be z, and this angle is going to be, I guess, like, theta, or actually, let's not use theta right here. Let's go ahead and use a different variable. Let's go ahead and use gamma, for example, for right now, just so that we don't get it mixed up. The law of cosine says the following. So law of cosine, I have z squared is equal to x squared plus y squared minus 2 times x times y times the cosine of angle gamma. And in our picture for the circle, that's exactly what we have. So what we can do is make a direct substitution. So first of all, z, I notice is going to be the radius of the circle, so we can go ahead and replace it with that. That's r squared is equal to x is supposed to be the variable r in this case, so we'll go ahead and make a substitution right there. I think I actually mixed up, so let me just go ahead and make a quick change. Z is actually equal to this radius of the circle, so that means that that's actually equal to a. So let me go ahead and replace, and I apologize for that. So go back here. So let's see, a squared is equal to r squared, and then that's going to be plus r of 1 squared minus 2 times r of 1 multiplied by the cosine of theta minus theta of 1. So this is going to be our equation of the circle in polar form. Now, normally this is something that I will not ask my students to memorize because it's really just kind of tedious for the most part. But for this example that I'm going to give next, we can just go ahead and apply a plugin, and we'll just go use it and just to see how it goes. I usually give this equation on a test if the time comes, so then they can actually just plug stuff into. So here's an example of what we just did right here. Find the equation of the circle in polar form with the center located at 10 comma 7 pi over 6 and also the radius of 6. And note that over here, when I wrote this right here, that is supposed to be in polar form because you'll notice that we have actually some brackets to actually work with. In some textbooks, you actually see it as 10 comma 7 pi over 6, and that could be very misleading because you don't know if that's Cartesian or polar because, well, both of the values are just something that's in radian form. So for me, I usually like it write it in bracket form if possible. But anyhow, going back to my question earlier, I want to find the equation of a circle with these characteristics over here. Now, I know that we can do, one thing that we can do is take all of this and change it back into Cartesian so that it's in terms of x and y, and then afterward change it back into polar. And that's actually a lot of steps. And again, that's what I want to avoid. So for the sake of using the equation that we just came up with, let's go ahead and try to see how that applies over here. So first, let me go ahead and write it back again so then you can see what that equation is. It is supposed to be equal to a squared is equal to r squared plus r's of 1 squared, and then minus 2 times r's of 1 times the cosine of theta minus theta of 1. So we'll go ahead and